Hello, I'm Paul's son, and I'll be showing the platformer I made for B58. Sorry, I'm a little sick. So basically, you open this up, game ISM. All the settings here are for what you need. So you can open the bitmap display, 512. Oh, don't forget to set that to that register. And don't forget to connect the MIPS. Yeah, this is the code, I guess. But yeah. So once you run it, you immediately put it into the game. And so as you can see, for milestone 1, we have drawing, we have the player, and then we also have the other things on the screen. So that fulfills milestone 1. For milestone 2, as you can see, we have movement, we have jumping, we even have double jumping, and dash. And as you can see, like, we have collision with walls. So you can see I'm trying to move it to the wall. We collide with the ground as well, of course. And colliding with enemies. So in this case, the enemies or hazards are the spikes on the ground, which are drawn using red. For milestone 3, as you can see, when we pick up that coin, we get another one in the top left, and so that's just to indicate like how many coins you've picked up, and then like once you die or win, it'll show that. So that fulfills milestone 3 as well. So I'm just gonna play through the rest of it and explain milestone 4. So basically the first thing, obviously, is you can see like all these coins are just bobbing down different times as well. So those are just the moving objects for the first criterion. So we have object pickups hovering up and down. Sorry, that's the level editor. For the second one, we have these moving platforms, as you can see. So if I So you can see, if I can time this right, and you can see the horizontal ones will move you around, and when we get there, I'll show how it works. So we're just going to dash to get off of it. So we're going to just double jump to climb up here, grab that coin, be careful going off the edge, and then we'll wait for it to come back down. Yeah, there we go. Oh, too late. But yeah. As you can see, the elevators work fine. It's a little choppy on the way down, but that's okay. So we're just going to grab that coin there as well. And go back down on the elevator. And we're just going to wait here. So we're just going to jump there. Move to the left. We're do double jump and dash. And once you collect all of them, you win the game. So, yeah. And so for milestone 4, the things are, you have the moving platforms, you have the hovering coins, and you also have the double jump. Sorry. So yeah. Also, yeah, you can like restart anytime. You can see we placed the coin back, and you can also quit the game. So you can see over there. Don't worry about this. The way I guess I can talk about the code now. Let's close it. Okay. So pretty much what happens at the start is to ensure consistent frame rate, because for some reason like Mars, I don't know, it takes like, I don't know, it's very inconsistent in how long it takes to run the code. So we can use syscall 30. You can probably find it somewhere in here. Yeah, we can use syscall 30 to get the system time. And so we store that into S0, and we use some calling conventions sometimes to keep track of that. So over here is the input handler, pretty straightforward. If there's nothing detected, we just go straight to physics. Of course, if you press something else, yeah. So these are all the different like input handlers. So for the sake of making the controls not that silly, we have like different handlers we have handlers that run on multiple keys. It's like you can jump with space or W or even Shift W because like you want to like dash, which is activated by holding Shift. So the up handler, we check if we're on the ground. If we're on the ground, then yeah, we can jump. Otherwise, we're in the air, and we check if we have a double jump available, and then we just jump by basically moving the player up by 1 pixel, and then we like modify the velocity. So actually, the velocity system, or the player's position and velocities, we store them kind of as fixed points. So actually these represent coordinates like divided by 16. So this is to make like the physics smooth. So if I can like get the game up again, I can show you. So yeah, like you can see we have like the jumping, and then we also have like, I don't know if it's a little harder to catch, but you can see like our movement is like very fluid, and you can see like we basically have like sub-pixel velocities as well. So that's just to like make it easier to use. So for left and right, we have to modify a little because I made the physics so that like the friction while you're in the air is much lower than when you're on the ground. So when you're on the ground, you get a little bit more velocity added than when you're in the air. And then for the dash, I left some comments up here, but basically if we have dash, okay, so if we're on the ground, we're just gonna treat it as like walking left and right, because you only want to dash in the air, because that was just because of the limitations of MIPS input. And then the rest of this is pretty straightforward as well. So if you're in the air, if you don't have a dash, then it'll treat it as regular right. Otherwise, it'll give you some horizontal velocity and like also like give you some vertical velocity. So this is like 1 pixel per game tick upwards and 1 pixel per game tick right. Or no, sorry, what am I thinking? 3. Same with left dash. So then we have the game loop. So basically, the way it works is initially we basically make every object in the scene write itself to like a buffer. So we called it I called it the collision buffer. But it'll write itself there, and then so static platforms, spikes are pretty simple to implement. Dynamic platforms, they have a bit of logic, and coins are also like pretty simple to implement. They just check if there's a player nearby or close enough to pick them up. I'll get to those, and then after that we process the player, and then we just draw everything. So once again, we render to a different buffer, and then once we're done rendering, we copy it all. So that's to prevent the flickering. And then of course at the end, we check the elapsed time. So recall that in S0 we had the start at the end, and then we have some logic to determine whether or not we need to sleep. So we'll sleep for the difference between the MSBT, which I set to 50 milliseconds per tick, basically. So the game runs about 20 hertz. And then we'll just go back to the start. Okay, so try and move. I'm gonna skip that. Okay, so tick stack platforms, you can see we have a write rectangle function. So this will write these bits onto like a region defined by like the size. So if you go up, you can see like the struct for the static platform. So we have like the structure of all of those. But yeah, tick spike is similar. So tick dynamic platform is a little bit weirder. So yeah, there's lots of calculations. Basically, we grab the variables, the positions, and we basically want to move the platform in the direction, because the way we define it is we give it like a bounding box, but then we also give it a velocity and then 2 points that it'll go between. So once it gets to 1, it'll reverse. And then also we do some logic to check whether or not the player like collides with it or not. And then I also made the hitbox like slightly bigger on the top, so that's why I was able to ride this platform horizontally. And then basically we'll try to move the player, so that's what try move is. And the rest of this logic is just mostly tedious. So yeah, the coin is a little easier. It just checks if the player is close by, and it'll set itself as picked up. So the player's logic is pretty funky. Let's see how we're doing on time. Okay, we got time. Sorry. So basically, we check if the player's on the ground by moving it down and then doing a try move 0-0. So try move will succeed. Basically, what try move does is it'll move the player this many pixels in like the direction. So that's like a pixel offset, pixel delta, I guess. And then it'll return whether or not it succeeded or not using A0 and A1. So in the case that A1 is set, that means you died. Yeah, you dear. Yeah, so that just gives you the lost screen. And otherwise, you're not on the ground, so you just skip the stuff on the ground. So the stuff on the ground, it just resets the availability of dash and double jump, as well as like sets on ground, so that we don't have to perform this check each time we need to know if the player's on the ground. Okay, yeah, here's the tedious part. So basically, as I mentioned, okay, it's not really friction; it's more like damping. But basically, like the velocity will halve every tick. I think it's half. Yeah, I think it's. I think this is inaccurate. I think that's 50%. Yeah. Sorry. The comments are a bit outdated, but we will like reduce the velocity by that factor. But then we also want to like make it not reduce that much if you're in the air, because obviously like the friction in the air is less. So that's what this logic is for. So we use on ground some bit manipulation stuff to get a variable number of shifts. And we also clamp the horizontal velocity, just so it doesn't get too fast, because there's low friction in the air. So if you just held down like left or right, and then when we process the velocity, what we do is, so we calculate like the offset. Let's say like in one game tick, the player goes from here to here. What we'll do is we're gonna step along the X, and then we're gonna step along the Y. So every single, we got lots of register spam. Like it was too hard to reduce the register pressure for these calculations. So yeah, there's too many live variables. But basically, we just once again, like if you hit something, you die, obviously. Or if you hit red, you die. So that's pretty much what that is for. And yeah, if you hit something, it'll stop there. So this is so like if you fall fast, you don't like land floating above the ground. So we do the same for Y afterwards, so it's X and then Y. And then drawing the static platforms is easy, drawing the spikes are easy, dynamic platforms are easy. The coins, we have a little bit of logic to make the bob up and down, and we also like add they have a fourth parameter because I felt like making the struct size 4, so I just added one. But basically, it'll like control like the offset time of their like bobbing. So yeah, that's just like something fun I added. And then drawing the player is pretty easy. So for the score, it's also pretty simple. We just have a loop that draws rectangles. So we have a right rectangle function. And then we have the victory screens and the loss screens coded in here, because making a general purpose like font render was a little too hard for me. And yeah, for the restart, we basically just like busy loop. Oh well. So yeah, this is the function that just copies the back buffer to the front buffer, because we to avoid flickering. And then we have just a utility one that like clears the entire buffer, and the rectangle drawing. And that's pretty much all the code. I think the last half of this was just an overview of the code, in case you did want to know how it works. I probably should have given a heads up, but yeah, thank you.